One of the biggest challenges that I oftentimes hear from people is that they wonder, where do you start with performance tuning? And I've talked about things like the query store before and other things, but there's one tool that's been around forever. I mean, since the end of 2009. And for almost a decade, this tool has been the top performance tuning tool in the industry. That is the trace parser, okay? There was an AX 2009 version, an AX 2012 version, and now there's an even better Dynamics 365 version. This is absolutely critical because there's nothing worse than sitting over there watching the system not perform the way that it is. There's nothing worse than not having an issue or not having an answer for whenever the system starts to have trouble. And what the trace parser does is it basically tells us exactly what's wrong about, 96% of the time. So in this particular lecture, what we're gonna be doing and what we're gonna be covering is going to be the trace parser. We're gonna explain how to use it, explain where it helps, and you're gonna see that when you get that performance issue, like that system's running slow and no one can figure it out, this is going to be your tool of choice. One of the most common things that we have to do is we have to find our tracing tool, right? So here we have Dynamics, and I've said before that this tracing tool is actually very, very special because it's right there included with our standard development machine. So here's a development machine, and what I'm gonna do is I'm just gonna go into start right here, as you guys can see, and I'm gonna go ahead and type in right here, trace, and look at that. There's Dynamics 365 trace parser. So this is our primary tool, and what you can notice is that the trace parser appears right in our dev machine, so I'm just gonna run and open it. I don't know if you need to open it as an administrator, but I always do just because in other versions of Dynamics you would suffer if you didn't. And what it basically does is it connects to the data collector that's on Windows by default, and it allows you to run traces, and as you can see, it's gonna allow you to see everything, so you guys see here it is, open. And when it first comes up, it pops in and it says, okay, do you want to import an existing trace, which if you've taken one, or do you want to capture events? Okay, so you see how easy it is to be able to open. And once you get it open, now you've got the full range of possibilities. And you see that it's also free. So very, very significant tool for that particular reason, because it's just right there and it's been there for 10 years. Now, let's go through a couple of options here in the next part. And let's take a look and let's just go ahead and see what would happen if we had hardware. So you've got a classic thing where you're suspecting that you may not have a hardware. Maybe you have an on-prem implementation, or maybe you have a cloud implementation, but hardware is hardware. And there are times where you need to know what's really happening, right? So the trace parser is very, very interesting. You understand that it can actually be used for hardware. It can. And in fact, I've used it many, many times to diagnose hardware issues. Hardware issues aren't easy to diagnose, as we know. In fact, most of the time, I would say that about 80% of the wrong diagnosis tends to blame hardware when in fact it's something else. Trace parser can detect things like that. How? By looking at relative overall measures of performance. Let's see that here. Okay, so first thing you need to do is you're going to need to run a trace, all right? So to be able to run a trace, let's go ahead and go through those steps. So we're on the machine right here. And what I'm gonna do is I'm gonna temporarily get ready to run a trace by taking a look at the system, and I'm gonna choose a slow process. So let's get it all queued up. And the reason why you queue it up is because you don't want any other information coming in your trace. You wanna get as specific as possible. A very, very common got you that I commonly see is that people will start clicking all kinds of things and be clicking the trace for like 2 hours. Well, if that happens, you're gonna get gigabytes and gigabytes and gigabytes of information sometimes, unless you have nothing going on your system. But you'll still get a lot of extra information, and that can be a distraction. You want to try to make it to where you can read as few things as possible. So let's say that we have a customer who tells us that our purchase orders are going extremely slow every time we try to open up a purchase order. So I'm gonna go to the all purchase orders screen first, right there. Now, you can see over here the system's sort of queuing up, gearing up, and I'm like, what's going on? Is it my hardware? What's happening? I don't know right now, do I? And in fact, without the trace parser, it's very hard to know. You can a little bit with some things, but it takes a lot longer. So I'm looking at that, but what I really want to see is I've heard that the customers are also telling me that it's very, very slow to open up a purchase order. Maybe it's very, very slow to do something like waiving, load planning workbench. Maybe it's very, very slow to run master planning. Maybe it's very, very slow to recalculate, quantities based upon bombs. Who knows? You get the point. Now, what I'm gonna do is I'm gonna first come to the trace parser. So I've taken a backup of a database and I've restored it. Then I'm going to click on capture events, and that turns on trace parser. Now it's running at this point. It's running in the back end on the data collector. If you go into the data collector on the data collector part, you're going to actually see it running as soon as we hit start. So I'm going to just go ahead and get it, and I'm going to make sure that I have the import and open trace, and I'm going to save to a file, and I'm going to start. Now at this point, there's my trace right there, and I'm going to put it somewhere because it's going to start running at this point, and I'm going to put, let's put over here, Dynamics demo trace. Now I'm going to go ahead and start my trace up, which you guys can see it started. It auto starts, but you guys get the point. And now at this stage, I'm running a trace, okay? So I'm going to come back and I'm going to go ahead and click. And maybe the customer knows, like purchase order 0017 is always slow, right? So I'm in the cloud at the moment, so I'm going to click 0017. And I'm looking and I'm noticing a few things, right? I just clicked it. I'm like, wasn't too slow, but did something happen? Maybe the customer knows something. Who knows? I mean, you get the point. This is the beautiful thing about the trace parser. So now I'm going to take a look. I'm going to go inside. And I'm going to stop the trace and import it. Okay? So I have first written it out. Now I'm going to stop and import the trace. I also saved it to a file in case I need to export it somewhere else. That's very, very helpful. And you guys can see I'm doing this. Now, the trace parser works best from a development environment. Typically when you can reproduce the issue, and usually that means downloading the most current data. Locks and things like that are very hard to reproduce sometimes, but they're also very, very easy to see. Sometimes the reason for a lock is, in fact, slowness. So when we go inside of the trace parser here, so we take a look, we'll see in just a moment. Just give it just a moment here. Got it, coming in. And you see it starts loading these files, and you have to watch out for this because basically these big files, the bigger they are, the longer it takes to run. That's one of the key critical reasons why you do not want to, trust me, turn around and have gigabyte traces. Sometimes you have to, but usually you want to at least try to make them as small as possible. So here it comes over here. Got it. Now, coming in, let's go and take a look at the trace parser right there. And you see you get the screen and it's like, oh, look at all this stuff over here. But what is it? Well, at this stage, you just see a bunch of things coming in. What you notice is, let's see, you've got your timeline first. Now your timeline tells you what's been happening, right? You can see that there's 824, there was these sequence numbers where it was actually recording all of these activities. And you start to come over and you notice, hey, look at these activities. Like, for example, there was a SQL statement. There was an AX class that ran a batch. You see? You can see exactly what was running by XPP source. All right, believe it or not, this can be extremely helpful for a good reason. Sometimes if you see something like a SQL login or SQL Connect, and something's going on where it's taking way too long, like instead of 108.42, it's like 108 and then it skips over like 10 seconds. That can indicate that you're having some sort of network or hardware failure. Keep that in mind. This screen can become important because it can highlight things to you that you know should not be there. And you will see that even in the cloud. Trust me, I have. In fact, I see it every month. So that's one of the first things. And you see, you just get an idea of what happened. Like there was a ledger posting, there was whatever else. This first screen is a great view of all the events that happened. You see the method name, number sequence global. I mean, you got it all right there. You can see exactly where it was called. And if you've taken our development course, or if you know AX 365 development, then you know, or Dynamics 365, not AX, but Dynamics 365 Finance and now Supply Chain, you know that, this is the application class, the system global cache, right? The number sequence connection class. And there's the method right there that it's calling. So this screen is dynamite itself. I love this screen. Okay, believe it or not, I love the other screens also, maybe even more, but I do love this screen too. Because you see, it's very important because you can see what method was called. And you can see pauses and times by looking at the relative time that something started and ended. All right, so now for hardware, you're gonna be looking sometimes and just look and see. Was there an unusual pause? Was there some sort of skip, something like that? That's what I'm always looking for myself. Those will show you a lot of hardware events, or the last thing they can show you is application crashing events. But when that happens, everybody knows. Trust me. All right, next step. Now, this overview screen is very, very important because what it shows you is it shows you the time that it takes to be able to run the processes. Now, here's the thing that I always have. People always tell me, oh, but it's not running on the most powerful hardware, Brandon. And I always say it doesn't have to. What matters is the relative times. Yes, it's nice to see how fast things can go on the powerful hardware. Of course, we'd like to performance test, stress test, and see what we can do. And of course, hardware makes a difference. But still, you can also learn a lot just from looking at the relative times on these traces. Here, like for example, I know now that it spent 4 seconds just processing messages. Half the time processing messages means running SQL. Other times it does a couple other cache events and things, but usually, that gives you an idea. Here's the client payload. Interesting. So here's the call the table data method. Interestingly enough, it's telling me that there's probably something going on in SQL here. You see all these data methods taking all this time? Let's see if we can see something. Now I come down over here on the next part, and it's the X++ methods by exclusive duration, right? The inclusive methods included other methods. The exclusive methods, of course, include only those particular methods. And you notice, server finished task with info log. What? The batch process taking the longest. Okay, and wait, it ran 30 times. Why did the batch process run 30 times? Well, that's actually not unusual. Depends what the method is, probably some sort of loop. But I'm still getting a good idea. But when I start to look, interestingly enough, I see perch line history exist or latest version not archived. Interesting. First thing you do is, before you check code, look at SQL. 717 milliseconds. And you guys can see that when you look at this, update batch, set the end time, status, rec version. Interesting, right? Very, very interesting. And you can see budget check, integrator. Some of these things, 717 milliseconds and 608, these strongly hint that you're in need of some indexing or cleaning or archiving or something like that. So next up, let's go ahead and see. So when we finish on that part, we're not going to go into the code yet. We'll do that in a couple minutes. But you're going to now go in and you're going to find the session. Now, usually look for the session that had the most time because that's usually the one that acted naughty. Not always, but I can tell you about 95% of the time it's the one that has the largest amount of time. And you see this one, it's got this one right there, looks pretty big on the SQL aggregated time, right? So let's see. Now that we're into that session, the session gives us far more information because now we can see the SQL tab appear. Now with the SQL tab, you notice over here that you start to see, the top one was 94, and wait a minute. Look at this. It's the SQL statement. So this means you can actually take the SQL statement and run an analysis on the SQL statement through SQL. And if you watch some of my previous videos, I showed you how to do that. Set statistics IO on, set statistics time on. So I just want you to go ahead and repeat that too. And you've seen that in my previous tutorials and videos where I've shown it, so I won't cover how to analyze the SQL over here. But I will tell you this, once you've got the SQL, you've got half the battle. If it's hardware. Ordinarily, hardware will always show up with SQL, just to tell you, in the cloud, almost usually. So you'll see it very, very commonly. But it'll also tell you something else too. You can also look at the query plan and examine it. So humongous benefit. Take the SQL statement and simply run it yourself and see the speed. If you're getting very, very slow speeds, then you might be needing indexing or probably changing the logic of the SQL statement. That's what oftentimes I do. And you see, having the parameters also tells you what it's running slow. Maybe a user's going in, like I've seen before, and they're searching a report and they're searching for all the years of the company and all the dates of the company. Let me tell you, the bigger the company gets, that gets slow quick. You don't want to see that. All right, sometimes though you might be looking, you might be like, well, God, I need to see the tables, not the statements. Okay, fine. Then you can sort the tables. Let's click name. And you see how I've sorted it? And what you look for is look for unusual counts also. Those tell you looping statements or things that sometimes shouldn't happen. When stuff starts acting up, you'll see counts sometimes it'll be like 100,000 SQL statements. Let me tell you something. No matter what you do optimizing, if you've got 100,000 SQL statements trying to run, there's going to be a certain amount of time it's going to take. It can be faster, it can be slower, but trust me, it can be slow. Or it's going to take some time. That's just the end of the day. So very important. And I look very, very commonly at this because you'll see a number just pop out. 388 doesn't really pop out, to be honest with you. And I know that from experience. But start to look at the numbers that go to the thousands, and I promise you, you will see it pop out. Believe me. So that goes for the SQL statement. So you guys see, look at the SQL very, very closely. Now, the other thing is, if you look at the call tree, very often, whenever it's a hardware problem, you'll see this weird case of events like this that'll just suddenly hang, and they'll hang, but then you'll look and you'll see that the same event runs a lot faster, like on your dev machine, than it did on some powerful, machine. Very, very common. Very, very common. That tells you hardware was a problem. If you have too many users or something like that, look for relative numbers like that to be able to tell you that there's a hardware issue. So keep that in mind, that for hardware, we look at these big numbers popping out and we look at SQL statements, and that's the first tip. Now, are there 1,000 other ways to diagnose hardware? Oh yes, there are. But this would be the first part with the trace parser. Look at those times. They're gonna cue you in very, very specifically, particularly SQL. And also too, later on, start looking at events like, setting a connection, things like that are hanging. That'll give you a lot of context many times into something occurring. Like the AOS will oftentimes hang on connections whenever there's a bottleneck in performance. That's something I found very, very commonly.
Software issues are really going to be the root of your issues, not necessarily due to bad code, although bad code can be a problem though. But the reason why software issues tend to show up so much is because of the fact that oftentimes the code does not align with the assumptions of the ERP application. That's the main reason. Now you can fix that, but first you got to identify which code's not aligning. That's where we're going to utilize the trace parser as our hero. You'll be seeing that.
So whenever we're looking at software, very, very commonly, I want you to go ahead and see that if you look at the X++, it's going to be the single biggest thing that you're going to notice, because the X++ tells you what's going on, right? It tells you the call stack. Look over here. And you can see that with this call stack, you can now see, oh, what exactly called it. This is extremely helpful. Now, this time you're paying attention to something else, inclusive time. Not exclusive, inclusive. Because you're looking at that call stack and you're looking for what's hanging, and you're trying to find it. Many, many times it's the aggregated form of the events that get called and the time that they get called that affects it. So you're looking at that inclusive time and you're looking at the count, and that's what's cueing you in. Like, why did something call itself so many times? Here, there's nothing. Let's go to another event. We tried the biggest, let's go over here, because this time this is a little bit bigger. So we're gonna switch up now, again, and you see there's 4 seconds right there, total, inside of our aggregated. And we're gonna go into our call tree. And we're gonna go to X++. And this time we're gonna go ahead and sort it. There's our total inclusive processing a message, right? Again, but perch line display method. Look at that. And we see what calls it, the process message, right? Then there's the client payload. Then there's the call data method. And right in here, we can start to see in the bottom, there's the code that's causing the issue. In the old days, if it's not locked, you just turn around and comment it out and see how fast something runs and see if it makes a big difference. But you'll see a high count and you'll see a high amount of exclusive time. Many times you can tinker with the methods in code right here and get them to go much faster, and you have to do that. Or sometimes the methods won't quite match the business assumptions. So that's what it means with the software. So very common on software, your X++ screen is going to be your hero, because you're looking at that count. How many times is it being called, which is usually the culprit, and then after that, the total inclusive. Every once in a while though, you'll see total inclusive hang just because it's a poor performing SQL statement. Poor performing SQL statements happen. Let me tell you, they happen a lot. So when you see something like that, you want to go ahead and watch it. But you see, what's happening is you're getting this feel for it. And if you notice, what I've said is, always pay attention to the counts. Pay attention to inclusive, especially when it comes to software. Sometimes you'll see a high exclusive. And I said that for hardware, always pay attention to the database and look for other things like connection events, kernel events, things like that. So you understand exactly how this works. Now, going a little bit further. If you want to get an overall picture, sometimes you will. Sometimes you'll look and you won't see anything. The most advanced thing by far to do is to go into the call tree, because only here can you really see a full picture. Sometimes you'll look and nothing really stands out until you go in and you start diving. Kernel level errors will oftentimes be detected this way. You'll see something hanging in the kernel, and sure enough, About half the time where I've isolated, kernels are not easy to isolate. You've got to look at them very, very carefully, and it does require some experience because you're seeing events that normally aren't addressed. But what you'll notice is very common, the kernel level events, I find will be addressed by Microsoft in some future update. I've had several of them that were addressed. The latest that was ever addressed that I found was about 11 months later. You can code around kernel events too, but it's a lot harder. Like for example, you have to go out and use a different control or something like that, And sometimes with extensions, it can really get hard, but it is possible. I have done it. So just letting you guys know that can be there. All right. So that pretty much explains all of that right there. And that's the trace parser. You ought to try it out. Let me know what you guys think. It's a pretty awesome tool. Practice, practice, practice makes perfect. In this particular case though, let's just go through and do a final little wrap up and look at it. So I said that maybe something was going slow, right? We first looked at SQL and we saw batch job, we saw things like that, but what really caused it to take a couple of seconds clicking in there? Let's see. Well, there's our call tree. We see right here that we have 1.7 seconds of processed messages, right? It sent out a broadcast right here. It sent a form notified. So right now you're noticing it's all just basic kernel stuff, really. Info essentials, documents, all this stuff is built in. Research the subscriber. What are you gonna change here? There's no custom code. Nothing, I mean, it's just basic. Why did it take over almost 2 seconds? That's hardware. That's just a dev environment. Now, how did I know that? Easy. Because you would have seen it holding a lot longer, or you would have noticed it holding for minutes, but in this particular case, that was it. So guys, that pretty much wraps that up. Now, one thing I want to tell you guys is that I want to thank you guys a lot for having listened to this particular part and checked it out. And I want you guys to go ahead and try it out yourselves. And I think you'll see that it's extremely beneficial to be able to practice this just like that and try to read it and, try to go over what you think, maybe post or something like that on the video if you've got a good trace or something and take a quick look at it or something. But it's extremely helpful. Not probably, but it's the most powerful tool that I've used in all performance tuning for the nearly for the last decade. That's pretty incredible. Decade at this stage. All right. I think you guys will like that. Okay, let's go ahead and turn on the camera real quick and talk for a second.
Probably the biggest thing that you've seen over here is that you've noticed that the trace parser is an amazing tool, a great place to start performance tuning. And you've also seen that when you go with the trace parser, you're looking at an inherent tool that's going to give you software, hardware. It's not going to cost you anything extra, and it's going to be able to get deeper than pretty much any other tool available today on the current market. That's why this is such an important tool to master in your set. Right now, things are getting more complicated. There's more and more business processes required to compete. Every month, I do things like master planning. I do supply chains. I do transportation. I do all those sorts of things, right? That I'm troubleshooting slower issues on. But I can tell you this, every single month too, I'm also using the trace parser, and it still works today just as well as it worked back in, 2012. New version, but just as well. So that's the big thing that I wanted you guys to take from this particular lecture, that you can actually see that this is our tool of choice. This is how you get an introduction in using it, and now you can utilize that for your performance tuning. Now you all, I just want to tell you, we have a lot of great tutorials coming up. We've been working pretty hard on them, and you guys may have seen things like our recent 25-part series on the techno-functional data model. Reports coming, performance tuning. This is just the beginning. We're just getting started. I want to thank all of you so much for all the kind emails and all the kind messages and the LinkedIn messages that I've gotten. And of course, the feedback has just been great. And at conferences, I couldn't hope for any more. And I promise you guys that we're going to work very, very hard to try to keep the quality up and make sure that we get out some very strong things. Now, as always, remember that you can go ahead and you can check out our training, which is extremely in-depth. In fact, our Dynamics course has over 60 hours of development compared to the regular course that's actually provisioned for around 20. So that ought to give you an idea of just how comprehensive it is, and it is comprehensive. And also in our consulting, I'm still out there every day. I take my little team of 4 people and we get out there and we do some serious tuning. If you need any help, don't hesitate to reach out to me. And again, as always, thank you all very, very much.